Have you ever pondered the scenario in which one of the brightest stars in the sky suddenly loses its radiance? This is precisely what occurred to Betelgeuse, a red supergiant star in the Orion constellation. Betelgeuse is an enormous star, approximately 20 times the mass and 900 times the radius of our Sun. Additionally, it stands as one of the closest supergiants to Earth, situated just about 700 light-years away. As a variable star, it experiences fluctuations in brightness due to pulsations and dust emissions. However, it recently underwent an unprecedented dimming, shedding more than 2/3 of its luminosity over a brief span. This event was termed the Great Dimming of Betelgeuse and generated significant speculation and interest among both astronomers and the general public. The questions arose: was Betelgeuse on the brink of a supernova explosion? Was this a manifestation of a mysterious internal phenomenon? Or was it simply a part of its natural variability cycle? In this video, we will provide answers to these inquiries and delve into the new study that unveils the cause behind the Great Dimming of Betelgeuse. Furthermore, we will explore the implications and importance of this study in enhancing our comprehension of Betelgeuse and other red supergiants. Additionally, we will debunk common misconceptions and myths associated with Betelgeuse and its dimming event. So, stay tuned as we embark on an exploration of the enigmatic aspects of this captivating star. The dimming's underlying cause lies in the primary findings of the recent study, which relies on high-resolution imagery obtained from the European Southern Observatory, or ESO. This intergovernmental organization operates some of the world's most advanced telescopes and scientific instruments situated in Chile. Among these instruments, one named SPHERE, which stands for Spectrometric High-Contrast Exoplanet Research, was employed. SPHERE's primary purpose is to capture and analyze exoplanets, or planets beyond our solar system, achieved by blocking out the intense illumination emanating from their host stars. However, SPHERE's capabilities extend beyond exoplanet research, encompassing the imaging and examination of other celestial objects, including Betelgeuse. The images obtained through this observation revealed a significant revelation. Betelgeuse's photosphere, its visible surface, was partially concealed by a cloud of dust originating from silicon monoxide molecules. In the vacuum of space, these molecules can aggregate into dust particles when their temperature decreases. Consequently, it is highly probable that this dust cloud was expelled from Betelgeuse's surface through a large convective cell, a phenomenon brought about by the star's pulsations and inherent instability. Within convective cells, hot gas ascends while cold gas descends, engendering a circular motion responsible for the transport of energy and matter. Betelgeuse boasts expansive convective cells that can blanket up to half of its surface at any given time. Moreover, these cells have the capacity to generate shock waves, thereby propelling gas and dust away from the star. The imagery obtained from SPHERE distinctly displayed one of these convective cells positioned in Betelgeuse's southern hemisphere, coinciding with the presence of the dust cloud. This dust cloud obscured approximately 50% of the light emanating from this particular hemisphere, rendering it noticeably dimmer compared to the rest of the star. Additionally, the dust cloud exhibited an asymmetric nature, characterized by irregular shapes and varying sizes. This asymmetry elucidates why Betelgeuse's dimming was not uniform across its surface, exhibiting variations contingent on factors such as viewing angles and wavelengths. Notably, the images unveiled that Betelgeuse's photosphere, its visible surface, underwent minimal changes in both size and temperature during the dimming event. This suggests that Betelgeuse did not undergo significant contractions or cooling, contrary to certain previous conjectures. Instead, the primary contributor to the dimming phenomenon was the dust cloud itself, responsible for scattering and absorbing a portion of the star's luminosity. The ramifications of this recent study extend far and wide, offering valuable insights into our comprehension of Betelgeuse and similar red supergiants. Firstly, the study provides a definitive explanation for the dimming event, which had previously been a subject of speculation, attributed to factors such as temperature fluctuations, magnetic influences, or stellar rotation. It unequivocally demonstrates that the formation of dust plays a pivotal role in modulating the luminosity and visual attributes of Betelgeuse. Furthermore, it elucidates that this dust formation process can be initiated by the presence of convective cells on the star's surface. Secondly, the study underscores the capabilities of contemporary telescopes and scientific instruments to capture unprecedented levels of detail regarding stellar phenomena. The images acquired through SPHERE represent some of the highest resolution depictions ever acquired of Betelgeuse's surface. These images unveil features as diminutive as 37 million kilometers in diameter, which is roughly equivalent to 25 times the Earth's own diameter. Additionally, the images encompass a spectrum of wavelengths, encompassing visible, infrared, and polarized light. This comprehensive array of data has unveiled diverse facets of Betelgeuse's atmosphere and the enigmatic dust cloud surrounding it. Finally, the study presents a host of new inquiries and challenges for forthcoming research endeavors. For instance, it prompts us to investigate the frequency and magnitude of dust production by Betelgeuse and how this process influences its trajectory and ultimate destiny. Moreover, it beckons us to explore the intricate interplay between the dust, the star's magnetic field, and its wind, all of which collectively shape the star's environment. Another intriguing query revolves around the influence of this dust on the detection and characterization of exoplanets that may exist in proximity to Betelgeuse. Lastly, the study paves the way for an examination of the prevalence and diversity of dust formation and dimming events among other red supergiants within our galaxy and beyond. A common misconception about Betelgeuse revolves around the belief that it's on the verge of a supernova explosion. While it's an aging star displaying erratic behavior, the reality is that a supernova occurs when a massive star depletes its nuclear fuel and collapses under gravity. Betelgeuse is a candidate for a future supernova, but it won't happen in our lifetime, or even for thousands of years. It has millennia left before potential implosion, with an uncertain timeline influenced by factors like mass, rotation, composition, and structure. The 2021 dimming event wasn't a sign of imminent supernova, but a normal variability phase unrelated to its core. Betelgeuse has since returned to its usual luminosity. Another misconception involves the threat a Betelgeuse supernova might pose to Earth. Supernovae are powerful, but Betelgeuse is approximately 700 light-years away. Light from the star takes 700 years to reach us, ensuring safety. Even if it's supernovaed now, it would be just slightly brighter than the full moon, observable during the day but not blinding. It wouldn't emit enough gamma rays or neutrinos to affect us. We trust that you found this video both enjoyable and enlightening, gaining fresh insights into this captivating celestial entity. Betelgeuse, with its unique characteristics and enigmatic behavior, serves as a captivating enigma that continually tests the boundaries of our comprehension and sparks our imaginative faculties. Moreover, it graces our night sky with its mesmerizing presence, offering a reminder of the boundless marvels and riddles that the universe holds. What aspect of Betelgeuse's behavior, or the science behind it, intrigues you the most? Are there any other celestial phenomena or stars you're curious about? Share your insights and opinions. Don't forget to hit that subscribe button and ring the notification bell so you never miss out on our exciting updates about lunar discoveries and the future of space exploration. Remember, as we venture into the universe, the sky is not the limit, it's just the beginning. Keep looking up.